One of the best ways to become familiar with the Energy2D interface and with the capabilities is to look at the example files. So here under examples, we have a number of categories, but I think that for us we might find the building energy analysis and the industrial applications particularly interesting. For example, let's open the solar chimney. Go ahead and hit the Run button to start the simulation. And we see the rays of sunlight, as shown here by these dashed lines. We also see streamlines that are indicating the flow of air through the simulation. We're starting to see a little bit of color down here, a little blue and a little yellow. That's indicating temperature. If I wanted to look at another one, for example, let's look at the thermal bridge and click Run. In this case, it's 0 degrees Celsius out here, 20 degrees Celsius coming from this material. So we're watching the heat actually move directly through the stud, and we can see that the insulation is impeding some of that movement of heat. Let's look at one more. In industrial applications, we have our friend the trom wall. Again, we have the rays of sun. We can see the rainbow colors indicating heat, where white is the hottest, and then it goes down red through blue, progressively getting cooler. We can see here some anemometers, which can tell us the airspeed, and thermometers, which are telling us the air temperature. All of these example files are potentially editable, so you could do a save as and make modifications to the example file if you wanted to use this as a starting point. Let's go ahead and make our own file, so I'd like you to go File, New. And the first thing is to right-click on the background and go to Properties. Let's change the size of our environment to 20 meters, and we can leave the height at 10 meters. Under Medium, let's set our background temperature. I'm going to go ahead and set it to 20 degrees Celsius and click OK. I'd also like to right-click again on the background and go to View Options. These are all of the different types of data visualization that are available to you through Energy2D. Depending on what it is you're studying, you might find some of them actually more appropriate than others. But one thing I do want you to turn on is here in your Visualization tab. You can have it so that by default your mouse will always be giving you a live reading, and I like to set that for temperature and click OK. So now everywhere that I move my mouse I can get a temperature reading. Let's go ahead and draw a ground. So I'm going to get my rectangle tool and roughly draw a rectangle down towards the bottom of the screen. I want to select that rectangle, right mouse click, and hit Properties. First, for my geometry, I know that the width of my environment is 20 meters, so I want to set this to be 20 meters wide, and let's set it to be 2 meters tall. And then I want to center it, so I'll hit my center to be 10 and 1. Let's go ahead and go back into it, Properties again. For source, I would like you to set that this is not a heat source. But let's change the temperature so that the ground is cooler than the air. So I'm going to change it so that it's 10 degrees Celsius. Under my thermal properties, I'd like to set my conductivity to 0.001, 2050 for my density. Since this is the Earth, we actually don't want it to be very conductive of heat. We want it to have a pretty high heat capacity and a high density. For optical, make sure your absorptivity is set to 1, transmissivity to 0. And then let's go to the Miscellaneous tab and give it a name. One more thing I'd like to do just for enhancing the visualization is if I right-click one more time and click View Options, you can actually give it a hatch pattern or change the color. In order to give a hatch pattern, pull down the menu, go to Texture, and select a pattern. Click OK. Next, I'd like to add a couple of thermometers, so we just click here in the menu. Let's put one at the ground and one in the air. We can already run a simulation just with this slight temperature change between the air temperature and the ground temperature. and we would start to see some convection and conduction where the air is actually being cooled by the ground. Let's right-click on the background and let's turn on the sun. In the Properties menu, check Sunny, and then I can go to my sunlight panel and change the number of rays, the solar power density, and then also the sun angle. If I leave it at 90, that's kind of the equivalent to noon. I want it to be a little bit in the afternoon. And click OK. And now if I run again, I see those solar rays coming and hitting the ground. I more or less have my environment set at this point. Again, you can change the background temperature, the air temperature, the ground temperature. You can modify the sun angle to suit your experimental question. But let's go ahead and start building some of our objects. So we might want to start with a floor, for example, and perhaps this is set a little bit off of the ground. This is my scale where I can approximate that this is 2 meters distance. So let's put my floor. Then I can right mouse click on that object, go to the properties. I can change the size of it. Maybe I want it to be 8 meters wide. I can decide if this is a heat source. So if you were interested in something like a radiant heated floor, you actually could make the floor a heat source. You can also make it a source of cool. It could be a radiant cooled floor. I can change my thermal properties, and I have some suggestions for you for floors and roofs and walls. So for thermal conductivity, let's put this at 0.05 and leave the heat and density, the specific heat and density. And in the case of solid elements, we want to just leave the absorptivity to 1 and the others at 0. Go to miscellaneous and give this the label floor. If I wanted to make a glass wall, right-click for properties. This time I want to go to my thermal tab, and for glass, let's make it 0.01, 1300 with a density of 10. And then for our optical transmission, we actually want to make it not absorptive, but completely transmissive. So really no material works in that simplified of a manner. All materials reflect, all materials absorb, and all emit. So this is an approximation, but it's okay. It's okay for this simulation. We want it to not be a heat source, but we probably do want to set the temperature so that it's the same temperature as the outside air. Since this is a window, I'm going to right mouse click and go to my view options and just change the color. Okay, and then I can continue in the same manner to create the roofs and the rest of the structure. Once you've modeled all of your windows, roofs, and walls, you can go ahead and run a simulation. In some cases, you might get an error that says that you need to change your step length, your time step length. In that case, what we're actually going to do is change the medium and go to the viscosity of the medium, and we want to make that about 10 times greater, which means we'll just remove one of these zeros. If I wanted to be able to measure the velocity of air, I could put an anemometer. If I wanted to actually visually see the convective flows, I could go to View Options, turn on my streamlines. If I would prefer to see the temperature contours, I could turn on my isotherms. Now might be a good time to add a little bit more heat to this model. So I'm going to simulate having a person in here. And this time the person actually is a heat source. So a heat source at a constant temperature Let's say at body temperature they're giving off about 35 degrees Celsius heat. You can run the simulation again. We can see that our interior space is warming up pretty rapidly now. Let's compare that if we actually put an insulated floor, because right now, remember, we have a cool ground. So again, we can add another element. For insulation, let's set this to our ambient air temperature, and we want our conductivity to be very low. Run another simulation. Let's see if we're starting to warm up inside faster than outside. It's definitely getting warmer. We can see we're starting to get some stack effect in the chimney. Let's change the sun angle so we get a little bit more sunlight into the space. You also have some temporary heat sources or cool sources. So if we click this option, I can add a little bit of heat to the space and basically watch how it flows through the space. Or I can hit Shift and click to add a bit of cold. There are a couple of other options. I can insert a fan if I wanted to see the effects of a ceiling fan in the space. This guy a little bit smaller. And because it's pointing down, I want to set the velocity to be a negative number. How about if we try 1/4 meter per second? We can see a pretty drastic effect caused by the fan. One more thing we can add here particle, which means that we can just drop some particles in the space and watch how they flow. We can also add a particle generator, a particle feeder. If you still get the fatal error, one thing we should try is we should turn the fan speed down. Okay, and that should be enough to get you started.